Welcome to The Explainer. So today we're tackling a really fundamental question in AI. How do you get a machine to learn continuously, for its whole life, just like a person does?
So, what if learning a new language made you forget how to ride a bike? I mean, it sounds absurd, right? You learn Spanish, and it doesn't just delete your ability to pedal. But for a lot of AI models out there, that's exactly what happens. Learning something new can be totally destructive to what it already knows. And that, right there, is the core of the problem we're going to dig into.
This whole issue, this forgetting problem, it actually has a name. And honestly, solving it is one of the biggest roadblocks to creating AI that can truly learn and adapt out in the real world.
It's called catastrophic forgetting, and the name is pretty spot on. You pour new information into a neural network, and as it tries to learn this new thing, it just, poof, it completely overwrites what it knew before. The new knowledge literally, catastrophically destroys the old.
So how does this actually happen? Well, here's the play-by-play. First, you've got a network that's perfectly tuned for, let's say, task A. All its internal connections, its little knobs and dials, are set just right. But then you introduce task B. To learn that, the network has to start twisting all those dials again. And in the process, it completely messes up the exact settings that made it so good at task A. It's an accidental but total wipeout.
Okay, so how do we fix this mess? Well, researchers have come up with some pretty brilliant ideas. And one of the coolest ones isn't about some fancy software patch, but about actually changing the AI's brain itself, its physical structure, its architecture. And the core idea here is it's just so simple and elegant. If you need to store more stuff, you don't try to cram it into the same old box. No, you just build a bigger box. Instead of just changing the software, you physically grow the network to make more room for new knowledge.
And this is a really important distinction to make. See, a lot of other solutions try to work within a fixed size network. They might try to protect certain important connections or constantly remind the AI of old data. But these architectural strategies, they do something totally different. They basically say, forget that, let's just grow the whole network. All right, let's dive into our first strategy. This one takes that idea of just make more room and pushes it to its most logical and maybe most extreme conclusion. This method is called progressive neural networks, PNNs for short. And yeah, the name itself kind of gives away the game, doesn't it? So here's how it works. When the AI needs to learn a new task, you don't change the original network at all. You just bolt on a brand new network right next to it. The library analogy is perfect here. You don't shove new books onto already full shelves. No, you just build a whole new wing for the new subject. Then you completely freeze the old wing. Its knowledge is perfectly safe, locked in place. And the new wing can learn its new stuff while still being connected to the old one, through these lateral connections or hallways. And the result? It's pretty incredible. Because you never, ever touch the old parts of the network, PNNs achieve, get this, zero catastrophic forgetting. Zero. The AI's performance on the old tasks doesn't drop one bit. It's basically a perfect memory machine. But you knew there had to be a catch, right? And it's a big one. This perfect memory comes at a huge cost. Since you're tacking on a whole new network for every single new task, the model just gets bigger and bigger and bigger. It becomes absolutely enormous and super expensive to run really, really fast. So that begs the question, how can you get the benefits of adding new space without the model just ballooning out of control? Well, that leads us to our second strategy, which is a much more elegant approach: grow and prune. This one works in a really cool cycle. Think of it like a gardener. First, there's the expansion phase. You let the network grow, adding new neurons and capacity so it can learn the new task. But then, after it's learned, you move to the contraction phase. You go in and you prune away all the dead wood, the inactive or redundant parts, to keep the whole thing efficient and healthy. And how does this stop the forgetting? Well, the key is what doesn't change. The core parts of the network, the bits that are crucial for the old tasks, are totally frozen. They're off limits. Only the new parts that you just added get trained on the new information. So you protect the old knowledge while still making room to learn. Okay, so when you look at these two strategies side by side, the endless expansion of PNNs versus the grow and prune method, you start to see this fundamental tension. It's a real dilemma for anyone trying to build an AI that can learn for a lifetime. And this chart really breaks it down nicely. You've got the PNNs, which just freeze everything to get that perfect recall.
Then you have expansion and pruning, which tries to be a bit more balanced by protecting a stable core. And there are even other methods, like online RBMs, that try to be more dynamic, only adding new neurons when they see something genuinely new. At the end of the day, they're all just different attempts to answer the same really hard question. So this is the trade-off, right? This is the core dilemma in a nutshell. You can go for perfect, flawless memory, but your model is going to get insanely big and unwieldy. Or you can go for efficiency, but you always run the risk of pruning away something that, oops, was actually pretty important. It's a constant, tricky balancing act. But you know what? Even if we found the absolute perfect balance between growth and efficiency, we're still not out of the woods. There are even bigger, almost philosophical hurdles to clear. Solving the mechanics of forgetting is one thing, but two massive challenges are still staring us in the face. And this quote just nails that second problem perfectly, the applicability of knowledge. Imagine an AI learns from 1,000,000 camera reviews that the word toy is a really bad thing, like a toy camera is a piece of junk. But what happens when you then ask it to review actual children's toys? That old knowledge is now actively harmful. It shows that context is absolutely everything. And that leaves us with the ultimate question, the one that the architects of these systems are really wrestling with. The goal isn't just to build a brain that can remember everything forever. The real challenge is building a brain that has the wisdom to know not just what it remembers, but when and how to use that memory. And figuring that out, well, that's the key to unlocking what's next for AI.